In this lecture, we will try to obtain decoder using demultiplexer. It is possible to operate a demux as a decoder. We will first obtain 2:4 decoder using 1:4 demux. We can also obtain 3:8 decoder using 1:8 demux. This will be more clear when we are done with this example. In 4:1 demux, we have 4 outputs y0 to y3, one input I along with 2 selector variables s0, s1. The input I is transferred to any of these outputs depending upon the value of selector variable. If s0 is 0 and s1 is 1, the input I is transferred to y2, and y2 is simply equal to I, and y0 is 0, y1 is 0, y3 is 0. So this is how demux operates. In case of decoder, we have 4 outputs, but we have 2 inputs. Instead of 1 input, we have 2 inputs, and depending upon the value of these inputs, I0, I1, out of these 4 outputs, one output will be high. For example, if I0 is 0, I1 is 1, then y2 is equal to 1, y0 is 0, y1 is 0, and y3 is 0. So this is the simple operation for decoder. Now we have to search for similarities between these two circuits. Before that, I will complete the table for 2:4 decoder. We have I1, I0 as the 2 inputs, and we have 4 outputs, y0, y1, y2, and y3. As there are 2 inputs, we are having 4 combinations. Okay, when I1 is 0, I0 is 0, it means y0 is 1. In the same way, for the second case, y1 is 1. For the third case, y2 is 1, and for the last case, y3 is 1. So this is the table for 2:4 decoder, and we have to search for similarities. The first similarity that we can see is the outputs. In this case, 1:4 demux, we have 4 outputs, y0 to y3, and in this case also we are having 4 outputs, y0 to y3. So we don't have to do anything with outputs. The next similarity that we can see is selector variables. In this case, we have 2 selector variables, s0, s1, and in this case we have 2 inputs, I0, I1. So we can use selector variables as inputs, right? Now what about this input I? What we can do with input I? We have to make this input I logic 1 permanently. This means we have to connect it with plus 5 volts. This is what we have to do with the input I. If you do all these things, if you consider S1, S0 as inputs, you connect I with permanent logic 1, then this circuit will operate as 2:4 decoder. Let's see how. When S0, S1 both are 0, 0, it means this input is transferred to y0, and y0 is 1. y0 is 1, and y1 is 0, y2 is 0, y3 is 0. This is what we have when s0 is 0 and s1 is 0. And I have already told you s0 is equal to I0 and s1 is equal to I1, right? So we can compare these results with this table, and we can cross check whether we are moving in right direction or not. y0 is 1, y1 is 0, y2 is 0, y3 is 0. So the first case is verified. Now we will move to second case. When s0 is 1, s1 is 0. In this case, the input I is transferred to y1, making y1 high, and rest all outputs are 0. We can verify it. When I0 is 1, I1 is 0. You can see y1 is high. So second case is also verified. For the third case, we have s1 as 1, s0 as 0, and in this case the input I will be transferred to y2. So y2 is high and rest all outputs are 0, and you can see y2 is high. So third case is also verified. And for the final case, when both selector variables are high, input I is transferred to y3, making y3 1, and rest all outputs are 0. Very simple. And you can see y3 is high. So all the 4 cases are verified, and this circuit is operating as 2:4 decoder. Fine. So this is all you have to do. If you want to obtain 3:8 decoder, then only thing you have to do is to make S0 equal to I0, S1 equal to I1, and S2 equal to I2. These are the selector variables of 1:8 demux, and you have to make input I equal to 1, right? 1:8 demux will operate as 3:8 decoder. So this is all for this presentation. If you have any doubt regarding any part of this presentation, you may ask in the comment section. See you in the next one.